participants joined it. Okay, the last class we discussed for the transaction. In that database, anything happen in the database system, we call that as a transaction. If you update, edit, delete, that's like. Now we are using here is the two type of transaction is there. Then if you make the transaction is a read and write. If you want to retrieve the data, you have to go into read mechanism. Okay, then if you insert or update or delete, after you want to write, that's a write mechanism. The two types they are already, we discussed the previous slide. Now I step that. Okay, the transaction is there, you active, then partially committed or committed. If your transaction is successfully, then you can commit. Okay, then particular transaction is failed, then you can approach, mean you can stop. That's a you can roll back. That's a you call rollback. Then transaction states are there. That's what is the state. Then we can commit. Commit means successfully complete. Then concurrent execution we are going to study deeply in next chapter. Therefore, I skip that. Is a concurrent control mean particular time, specific time, only one transaction. Okay, can execute for the right. If you many people can read the one of the particular record or particular items. We call here is the one record as item like. Okay, they can read, but only one person can modify. That modify is the right the transaction. That's the concurrent control. Okay, we are going to study for the next chapter for deeply for the concurrent control. Okay, then schedule a sequence of the instruction that specifies the chronological order. Then we want to put the schedule which transaction first execute and second. Sometimes some transaction depend for the another transaction. That's like that's a schedule. Okay, there is the schedule is there. We can sometimes we can interchange or sometimes not interchange. Okay, that's a schedule is there. Already we discussed for this schedule also. This the T1 read A, then subtract that. Okay, deduct the $50 or 50 rupees and write. Then read B at that one. Okay, the T2 after that T1, this time span, after that we start with another transaction. This is the continuously. Okay, this is not affected. If you make the same time, it's conflict. Okay, this is the another time. This is the one time period the committed. Like next this read A and calculate the 10% for amount and deduct that amount from the A and add that amount to B and write the B. If you deduct the amount, then you want to update. That's the right. Then read the balance of the B and again add that some amount and write the B and commit it. This is the second transaction that is a successfully complete. This transaction also we can interchange. First want to execute the T1 and T2, but that is not in the same time. Okay, it's the time frame is there. First want to execute the T1 and T2. This is it. We can give the schedule for the transaction. Okay. Sometimes this schedule also we can make partially. Read A, deduct 50 and after that read B, this amount is little less because already we deduct the 50. Okay, then read B at that one, again at the another one, it also schedule is the same result you can get. Okay, that's the equivalent to the schedule. Some schedules are equivalent to other schedule. But the different time period. Okay, the following concurrent schedule does not preserve the value A plus B because deduct that money, read, right? A temp, right? Read B here. Then write A. Then read B, add the 50, write B and commit. Then again this line. But this one is not concurrent. Okay. Now we come for the serializability transaction. Basic assumption, each transaction preserves the database consistent. There are no any harm. Thus, serial execution of the set of transactions preserves the database consistently. Okay, now we come for the two types of serializability. There, one is a conflict and view serializability. Okay, that's a schedule. Now you are simply view the of the transaction. We ignore operation other than read and write. Okay, we are only consider the operation as a read and write instruction. Okay, read and write. The read and write means that's some execution inside some operations are there. You can see here in the operation that is a deduct the money. But here is a write, read and write. But here some operation, other operation instructions here. Okay, we ignore that one and consider for the read and write. Okay, our simple schedule consists of only read and write exit. Now it's a conflict instruction. Now we had the two type of instruction, I and ij instruction, I1 and j of the transaction, ti and tj, the two transactions there. Okay, that is the respectively conflict if any, only if the exit sum of item q accessed by both. Okay, in this situation we are access only same item in the transaction, ti and tj. Okay, then if you separate item is there are no any effect for the transaction, but it's the same items are the item in queue. Item is the queue. Our instruction sorry, respective conflict if only, okay, if and if only they are exit some of the queue accessed by both I and j. Now you can see here I1 first stage. Okay, I read queue, want to read the queue. ij also read the queue. It is no problem because they are going to take the value or something. Okay, then ii and ij doesn't conflict. There are no any problem, no fight. Like that's a conflict means the fighting. That is the collision. That is the thing. There are no problem here. Okay, both are read like. But here I is going to read and ij is going to write. That's the conflict. At the same time, conflict. Where the balance is going to change. That's a conflict. Or here is a I write and ij read. Or ij write, sorry, write and ij also write. They are conflict. Then we want to give that is the schedule. Okay. Then conflict between ij and j forced a logical, okay, temporal order between them. Want to order. If ij and j are consecutive in the schedule, then they do not conflict. Okay, if you have the schedule, is no problem. But at the same time, if happen this one, both, because T1 and T2 is a different transaction, but both are using the same item Q item. Then instructions they are read. Okay, no problem. Both are going to read. There are no any changes. But read and write, they are going to change the value sum in the queue. That's a okay. Their results would be remain the same even if there had been interchange in the schedule also. Then conflict seriality. If the schedule S can be transformed into the schedule S dash, by a series of swap on non-conflict instruction. Okay, there are no any conflict, then they can interchange their schedule. Okay, then we call for conflict equivalent. We say that S and S are conflict equivalent. We say that schedule S is conflict seriability if the conflict equivalent to serial schedule. Okay, serial means continuous. Now you can see this is the one of the example T1, T2. Here read A, write A. Read A, write A, T2. Okay, read B, write B. There are two items there, not in the one item. Here is the two item, and T2 also has the two items. Okay, two items. Then we can interchange their schedule. Now here T1 and T2, that read A, write A. Read B, write B. Read A, write A. Read B, write B. Okay, here is a schedule 3 and schedule. They are compare. Okay, compare the two schedule. What's the problem? Schedule 3 can be transferred into the schedule 6, a serial schedule, where T1 followed by T2. Okay, if T1 is finished, okay, T1 followed by T2. There are no any problem. Therefore, schedule 3 is conflict seriable. Okay. Okay. If the T1 by series of swap on non-conflicting instruction, because here now is a swap, mean here come to the up this schedule, right? Read B and write B is come to up. Schedule is changed. Schedule means the time. Now you have the schedule means that you have the lectures, the schedule. Okay. At the same time, we can assign the another lectures for you. Okay, then your attendance is half of the other lectures, half of the my lectures. That's the schedule. Now this is also same, the transaction is the schedule. Now is the schedule is move up and this schedule is come down. T2 schedule, that's a trade. But no conflict. There are no problem. Then therefore, schedule 3 is conflict seriability. And we can make the seriability is okay. Okay. For example, now is this is the non-conflict seriability. We cannot make the seriability because here is the same items there. Q, read Q, then T4 going to write Q, then again write Q. T3 going to change or something. We are unable to swap the instruction. Okay, we can't go to the move write Q because there is a changes is happening for the Q in transaction 4. In the T4, they are going to change some value or some deduct or add or something we don't know, but the transaction is going that right. We are unable to swap instruction in the above schedule to obtain either serial schedule. Okay, or serial schedule T4 something. Okay, we cannot change because the same items there, but the previous is a different item. Therefore, we can make the serial. Okay, continuous schedule. Swap mean change, interchange, like swap. Okay, sometimes we are interchange for the lectures. Different schedules, they are unable to do my lectures for morning something. We can ask for the other people and interchange. That is the like here. Okay, but if the same person going to take the lectures, but it can't because in the another class, this is the another class. Okay, it is impossible. Therefore, this is the schedule can't interchange. Okay, the view seriability. Let's S and S be two schedules with the same set of transactions. S and S dash are view equivalent if the following three conditions are met for each data item Q. Okay, if the schedule S transaction Ti read the initial value of Q. Then in the schedule S dash also transaction Ti must be read initial value of Q. Okay, S dash also want to read that. If the schedule S transaction Ti execute the read Q and the value was produced by the transaction Tj. Okay, if any, then if the schedule S dash also transaction Ti must be read the value of the Q that was produced by the same write Q operation of the transaction Tj. Okay. The transaction, if any, that perform the final write operation in the schedule S must also perform the final Q. At the same time, the same amount want to write the other schedule also. Okay, that is the view seriability. Something happened at that time, we want to write that other side also. Okay, as can be seen, view the equivalent is also based on pure on read and write alone. Okay, it is separately read and write alone is there. Okay, view the serial. Now, a schedule is view the seriability if view equivalent to serial schedule. Okay. Even conflict seriability schedule is also view the seriability. Now this conflict is there because read Q and here T28 is a write. Something happened. Then write Q. Then the something happened here. That value is here. But we cannot interchange. Same value. Then write Q is a 29. Okay, but serial schedule is above equivalent. Okay, serial schedule is there, but we cannot interchange. Okay, then every view seriable schedule that is not conflict seriability has blind write. Okay, they are blind writing for the same value here at other same value here, but we cannot interchange. We can't interchange this. The schedule. The schedule is okay, serial, the continuous. Okay, other note, okay, notion of the seriality. Now, the schedule below produce the same outcome as the serial schedule T1 and T5. That not conflict equivalent to, okay, or view equivalent to it. Now you can say read A, deduct the 50 rupees and write. Read B, then deduct 10 and write. Okay, then after that, some deduction, we want to add A to B, that's the 50. And that deduction going to add this one, B. But this one is the total amount is the equal, no changes. Total amount is the no changes. The determines just, okay, equivalent recur analysis of the operation other than read and write. Okay, now we only check that is the balance. A has the A and B totally, their balance is not changed. Okay. Now test for the seriality. Consider some schedule of the setup T1, T2. Okay, then we can interchange for this graph. Okay, preceding graph. Sometimes give the preceding which one want to execute first and then follow up other one. Okay, that's a preceding graph. According to that, you can make the transaction. Okay, we row the arc from Ti to Tj. Arc means the arrow. Okay, if the transaction conflict and Tj access the data item on which the conflict arrows early. Okay, we may label the arc by the item was accessed. Then we can make that is a preceding graph for the T1 to T2 or T2 to T1. Okay, the test for the conflict serial. Now here we have the 4 transaction is there. Okay, now you can see that Tm is depend for the Tj and Tk transaction. Okay, they didn't give any instruction inside the what are the transaction, but they make the transaction. 1, 2. Okay. Then Ti. Then we can make this order. First execute the Ti, Tj, after Tk and Tn, or Ti, Tk, Tj and Tn. Okay, now is the it is the cyclic, but no, that arrow is going this like work, but it's coming for the Tn. Start the transaction Ti to Tn. Okay, and the schedule is conflict seriality if, and only if it, okay, precedent graph is acyclic. Okay, acyclic. Okay, the cyclic detection. Okay, detection algorithm exit which take order n times. Okay, where n is the number of vertex. The vertex means in the vertical axis. Vertex in the graph. Better algorithm take order n plus each. Okay, that's the number of h. E is the number of h. If the preceding graph is, okay, acyclic, the seriability order can be obtained by topological sorting. This one is a topological sorting you can execute. Okay, this is the topological sorting of the graph. This is the linear order consistent with the partial order of the graph. This is a linear mean continuous. There's a linear, no any. For example, is the seriability order for schedule A would be that T5, T1, T3, T4, T are the others. Now you can see that you can make this order. If you have the precedent graph, then you can make this order. Okay. Test for view seriability. The precedent graph test for conflict seriability cannot be used directly to the test for view seriability. Extension of, okay, extension to test for view seriability has cost exponential in the size of the precedent graph. Okay, you want to check the, if you have, here is the only few transactions here. If you have the many transactions, that's a different way you want to check for the transaction. That's the cost is expensive. Okay, exponential is the size of the precedent graph. The problem of checking if the schedule is view seriability fall in the call for NP complete problem. Okay, thus exit of the efficient algorithm is extremely unlikely. Okay, therefore we are using in the view seriability. However, practical algorithm just check for the sufficient condition for view the seriability can be still be used. Okay, we use that. Okay, now is the recoverable schedule. Okay, I also want to skip one. Later we study for the another chapter for the recoverable chapter. Okay, how to recover. If you have some recoverable schedule, if the transaction J, if the transaction J, so if the transaction J read the data item previously written by the transaction Tj, then the commit operation of the Ti appear before the commit operation in the Tj. Okay, the following schedule is there: T, read A, write A, read A and commit. Okay, then sometimes it happen for the read B is the failure or something. We want to recover. Then this want to undo that one also. Okay, if the T8 should abroad, the T9, okay, should abroad mean rollback. The problem is happen. Okay, so read and possible so into the user. It is inconsistent database state. Hence, the data must be ensured the schedule are recoverable. Then we want to recover for this, because we some read and write some changes there, but that changes want to happen in the B also. But the failures, the can't read the B. After can't do any operation in the abroad. Then we want to roll back. That's a recover schedule. Okay. Now we come for the cascading rollback. Is a single transaction fail lead to a series of transaction rollback? Okay. Now you can see the 3 transactions going to serial. Okay, continuous seriability. But in the T10 is failure. Then we want to roll back for the other 3 transactions, other 2 transactions also. Okay, must also. That's the aspect. Okay, we will study deep in the recovery chapter. Okay, that schedule also you can study. I want to discuss. Then concurrent control. Okay, the database must provide the mechanism that will ensure that all possible schedules are either conflict or view seriable and are recoverable or preferably for cascadeless. Okay. Then concurrent control, already I described, that is the particular time of the specific time only one item can modify. That's a concurrent control. Modify. A policy in which only one transaction can execute at a time. Okay, that's every time we grant. A policy in which only one transaction can execute at a time. Generate the serial schedule, but provide a poor degree of concurrency or a serial schedule recoverable or as well. Then if you have the schedule is bad, then it's unable to recover your transaction also. Test a schedule for seriability after if the execution is a little too late. Goal that develop the concurrence control protocol will assure the seriability. Then we want to develop the concurrent control protocol. The next chapter we are going to study for the concurrent control. Concurrent control. The schedule must be conflict or view seriability and recoverable for a shake of the database consistent and preferably cascadeless. A policy in which only one transaction can execute at a time generate the serial schedule, but provide the poor degree of the concurrence control. Concurrency control scheme rate off between the amount of concurrent they allow to allow and the amount of overhead that they ignore. Some scheme allow only conflict seriability schedule to be generated, while other allow view seriability schedule that are not conflict seriable. Okay, some scheme allow for the conflict seriability schedule and other non-view seriability also. Then concurrent control versus seriability test. The concurrent control protocol allow concurrent schedule, but ensure that the schedule are conflict or view seriability. Then we want to confirm is that there are no any conflict or that. Okay, we come for that concurrent protocol. They had some disadvantage also there. That also how to overcome for that advantage and disadvantage. Everything we want to discuss for the next chapter. Then concurrent control protocol generate do not examine the preceding graph as it is being created. Okay, they are not considered for preceding graph. Okay, the different concurrent control protocol provide the different rate of between the. There are some protocols there in the concurrent control. That's provide the different trade-off between the amount of concurrency they allow and the amount of overhead of their echo. Tests for the seriability help us and understand why the concurrent control protocol is correct. Okay, then we must need for the concurrent control. We don't know if you write for the many transaction in the seriability or something, we make a mistake. But if you have the concurrent control protocol, it is managed for that the transaction. Okay, weak level of the consistency. Some applications are willing to live with the weak level of the consistent schedules are not seriality. Therefore, we are making some schedule are not seriality. Read only transaction that want to get the approximately total balance of the all account. Okay, some situation is like that's a weak level consistency there. Okay, then level of the consistency in the SQL 92 seriality repeat. Okay, seriality is the default. Repeatable read only committed record to be repeated. Okay, failure not. Okay, read of the same record must be returned same value. However, transaction may not be seriable. Okay, seriable if may find some record insert by the transaction but not find others. Read committed. Only committed record can be read, but successfully read or record may return different value. Okay. Read uncommitted. Then we want to read the uncommitted. Even uncommitted record may be read. Okay. Then lower degree of consistent useful for gathering approximate information about the database. Then we want to handle our database. Then we want to need for the seriability schedule for the transaction. Some other example they make warning, some database system does not ensure the seriable schedule by default. Okay, for example, then Oracle, they had a concurrency control protocol. Okay, and PostgreSQL by default support level of the consistent called snapshot isolation. Okay, we are going to study this on in the next chapter. Okay, then transaction definition in the SQL. Data manipulation language must be included the construct for the specific set of action that compare the transaction. Okay, the transaction is happening, anything happening in the database. That's a transaction we call. In the SQL, transaction begin implicitly and transaction is SQL end by the commit work and rollback work. Commit, okay, current transaction and beginning the new one. Okay, commit means this is successfully complete. The rollback case, the current transaction is approved. Then rollback, if you make the rollback, like then the failures happen in the transaction, then you can go to the previous state. That's a rollback. In almost the all database system, by default, every SQL statement also commit implicitly if they execute successfully. Then implicit the commit can be turned off by the database directive. Okay, now then now you can understand the transaction you for the schedule. Without schedule, there is the problem for conflicts. Failure also sometimes. Then we want to make that a schedule for the transaction. Okay, that's a serial. Because that concurrent control is there at the particular time, only one transaction can execute. One transaction can execute the modify. That's a modification, right? Right transaction can execute. Okay, now we come for the concurrent control. It is important for in our database. Okay, lock-based control. Okay, lock-based protocol. Lock-based means that few one transaction is execute, lock that one, only particular person can use that one, other person can view. Okay, that's a lock. Time stamp based protocol. Then you can give the time. We will deeply discuss for the coming live. Okay, lock based protocol. A lock is the mechanism to control the concurrent access to the data items. Okay, we call the data item mean if you particular table, database has a table. Inside the table, particular row. Okay, record. That record means rows. It is a lock. For example, in the bank, every customer is a one table is there. Customer table, like we had the account balance or something. But lot of customer come, we cannot lock for that one. But if we can lock for the, if you want to, okay, withdraw the money for particular customer, then only that record can record, particular record, the account number, that particular one row can lock for the particular user. Okay, if you put the lock for the particular file or particular table, other person cannot use. Okay, other person cannot use. Therefore, we add that's a lock mean it's a particular record going to lock, not in the whole table also. Okay, the lock is the mechanism to control the concurrent access to the data item. Data item can be locked in two modes. One is the exclusive mode, other one is the share mode. The exclusive mode is the data item can be both read as well as write. Okay, then we call X lock is required using the lock X instruction. Other one is the share lock mode. Data item can be read S lock. If you put the S lock, data can be read. Then other person also can use it. That's a share. But exclusive means read and write. Therefore, other person can't use it. That's a lock. The lock requires a mode to concurrent control manager. The transaction can be proceed only after request is granted. Then if you want to use the particular row or something, first want to request for the concurrent control lock. Want to request the lock in the concurrent control manager. In the database here, that's the facility for the concurrent control manager. Then that manager grant for the deadlock. Then after that, they can use that particular record. Then that time they are going to modify. If you, for example, the exclusive mode is there, then they are going to write something. Then other person cannot use that record. That's the particular row. Record means particular. That's the locks. Then the transaction can be proceed only after request is granted. Okay, if your request is there, then if you grant it for the lock, then transaction can start. Lock compatibility matrix. If SSS true and XS, S and X, this is the exclusive, is a share. The transaction may be grant a lock on an item if the request lock is compatibility with the lock already held on the item by other transactions. A number of transactions can hold share locks on the item. Okay, the number of items. Any number of transactions can hold the share locks because share locks is the only read. Read means you can retrieve the balance or something. That's a read. Okay. For example, if they are make the lock for particular things, a share lock, then other person, if you, for example, in the bank, you want to balance your account, but you had a loan or something, they also want to check or to recover some money from your account, then loan balance want to settle, they want to view. Okay, but they cannot make the transaction. That's a share lock. Any number of transactions can hold the share lock on an item. Okay, on an item. The item we can make the many share lock. But if any transaction hold the exclusive lock on the item, no other transaction may be hold any lock. Okay, particular lock, particular row has a lock for the exclusive lock. Then any other transaction can't make for the lock, any lock item. Share lock or exclusive lock can't put it. We will study deeply in most like this there. Okay, in this chapter. If a lock cannot be granted, the requesting transaction is made to wait till all incompatibility lock held by the other transaction have been released. Okay, then if you one record, one item got the lock, then the transaction finish, then want to release that lock, then another transaction can use that item, use the particular item. Then here, if the lock cannot be granted, the request transaction is made to the wait. They are going to wait for the get the grant lock. Okay, waiting for the things. Then the lock is the then granted. After that, they can move. Now we say exclusive X mode. Okay, X mode. The lock X, sorry, XB, item B. Okay, exclusive lock. Read the B and deduct the money. Write B. After unlock, release. Then another transaction can use the B up to this stage. Okay, this is exclusive X mode. That's exclusive lock in the T1 transaction. Lock XB, that's a exclusive. X mean exclusive mode B. Then anyone cannot use anyone in that B. The other transaction cannot use it because this is a lock. B got a lock. The read B minus 50. Write B and unlock. After changes happen, that is committed, then unlock. Then lock A, read A plus 50, write A and unlock. Okay, already I explained this one, this situation. If you had a credit card or sorry, debit card, your ATM card, then same time, 2 person withdraw the money in same account. Only one account. Then if you put the ATM card, then your record is locked. Anyone can access. Okay, one person in with the passbook, then they cannot withdraw the money because that row is locked. After release the lock, then that particular person can withdraw the money because they are at the same account, the same row. Now it's a read A, add them that money 50 and write A unlock. Okay, this is the exclusive lock. Lock-based protocol, that's an example of the transaction for phone lock. This one is the share lock. Lock S, read A, unlock. Lock S, read B, lock B and read and unlock display plus B. Okay, then here is the, if make the share lock, other transaction also can use it that is A item. Okay, locking. Okay, locking as above is not sufficient to grant seriability. If A and B get update in between the read A and B is displayed, the sum would be wrong. Okay, but here we put the share lock. Okay, this time other transaction also share lock. Okay. Then between the A and B is display the sum would be wrong. Okay, it's unlocked. A and B, read A, read B, and display A plus. A locking protocol. Okay, locking protocol is set a rules followed by the all transaction while request and releasing the lock. Request and releasing the lock. Lock protocol restrict the set of possible schedule. Okay, that also as a possible schedule. Now you can see the transaction and execute concurrently. Okay, concurrently. There's a concurrent control manager grant that lock for which transaction. Here T1, T2 transactions there. 2 transactions there. Here lock XB, exclusive lock B. Then grant for the transaction T1. Read B and B minus 50, write B, unlock. Then now we here grant for the share lock. Okay, lock SA, read A, unlock A, lock S, grant T2N, read B, unlock B, display. Okay, another. Now is the grant for the lock A. Now you can see lock T, the transaction T2. T2 is the share lock. Now is the A has some amount. For example, this is the 1000. B has the 2000. Okay, B has a 2000. A has, okay, you can assume A has 1000. Now is the B deduct 50, then 1950. B. Now lock A, read A is a 1000. B 2000. Then 1000 plus 2000, sorry, now is the B is 1950. Then A plus B 2950. Okay, now this transaction display that like. But here T1 lock now is the 1950. Then put the grant for the exclusive lock for the A and again deduct the money 50 and unlock this. Okay, unlock that. Now here another 50 is down. Then the balance is how much? 1800. The balance is not same. Therefore, we make mostly that's a lock. Share lock is not changed. Any other transaction also can use it. View that lock. Okay, there's a different schedule is there. Before that, the amount is wrong. But this transaction is complete, you can get the actual balance. Okay. Pitfall of lock-based protocol. Consider the partial schedule T3, T4. Lock XB, read A, B minus 50, write B. This is a partial. Lock SA, read A, and lock SB. Okay, chair lock. Lock XA. Neither T3 or T4 can make progress. Execute the lock SB. Case T4 to wait for T3 release. Okay, now is the lock XB is there. Okay, if you release, then it can make for the lock B. Because if you make the exclusive lock is there in the T3, execute the T3, any other transaction cannot use for that lock B item. Okay, this is the pitfall. Then T3 release if lock B while executing the lock XA. Okay, then if you put the release the lock B, then it can make the lock A case. T3 to wait for T4. Now here is a lock SE there. He also release the lock. in T4 also want to release the lock. And when you put the lock, if execution is over, want to release the lock. In this situation, we call the deadlock because we cannot execute the both, can't complete the transaction. We cannot complete the transaction because we put the lock here, not release. Okay, not release. Because here lock is there here. But in here, lock A. In the T4, put the lock A, read A. There are no release for the lock A, lock SA. Then that this T3 cannot use for this here in the A. This is the lock. Okay, this situation we call deadlock. Okay, therefore we make the schedule also, the lock also, very careful if make deadlock. We want to avoid that deadlock. If you make the lock, execution is over, release the lock. Okay, then you had to write that release lock. Here, unlock B. Okay. Then here neither T3 or T4 can make progress. No, execute the lock SB case to T4 to wait or T3 to release the lock on B. While executing lock SA case T3 to wait, the T4 want to release the lock. When it's going to release the lock, it is waiting. If T4 release the lock A, then here T3 can use it the A. Lock A is possible. The same time the lock XB in the transaction T3, it release the lock, then the T4 can use, okay, make the lock in B. Lock in the B. Okay. It situation call for the deadlock. To handle the deadlock, one T3 or T4 must be rolled back and is lock released. And is lock released. Then we can't do it. In the situation they are waiting for both. It is impossible to execute. Then roll back the transaction. This situation, want to roll back the transaction. Okay, we call this a deadlock. It is a void for that thing. Okay, this is the deadlock for the database. In our programming also, this sometimes happen. One variable depend on the another variable, but that variable is depend for the same this variable. Like we cannot execute or complete our tasks. That we call deadlock. That I think you are studying the software development, something coupling. Tight coupling, like if you make the tight coupling for the one function for another function or depend for the function, if some changes happen, want to depend for the other function, like we make that. Okay, then we avoid this deadlock. Okay, then we carefully write the schedule. Okay, use the one lock is happen, execution is over, want to unlock that particular item. Okay, we call the item in the B is the some changes happen in the record B. That's the B. That is the A. Okay, A is another record. Okay. The potential for the deadlock exit is most lock protocol. The deadlock are necessary able. Then we want to avoid that deadlock. The starvation is also possible if concurrent control manager is badly designed. Okay, badly designed for this is like as a deadlock. Badly designed means there's a schedule. A transaction may be wait for an X lock on an item, while a sequence of other transaction requests are granted to X lock on the same item. Okay, they grant for the same item for that concurrent control manager. Manager make the mistake. Then therefore, we want to make the schedule. Okay. Or if you make the lock, then want to release the lock after the execution. Okay. Then we had this time span lock concurrent control. That is then particular time is waiting for the lock. Okay, lock is granted, then want to execute the particular time is over, then lock automatically release. There are no any situation for the deadlock. That is the time span concurrent control. Okay, the same transaction is repeatedly rolled back due to the deadlock. Okay, then that both transactions want to roll back because can't execute. A concurrent control manager can be designed to prevent the starvation. That's a deadlock situation want to prevent, avoid. The two-phase locks protocol. This is the protocol which ensure conflict serializability schedule. It's the growing phase. The transaction may obtain lock, but transaction may not be released lock. Two phases there. One phase is the growing phase. Transaction may obtain lock. The transaction manager grant that lock, then obtain that lock. Second phase is the stringing phase. The transaction may be release the lock, not to acquire the lock. Transaction may not be obtained lock. It's the two situations there. Here, transaction may be obtained lock, not release. Okay, then if you make the lock, two phase need, growing phase and stringing phase, because transaction may be released lock, but not to obtain the another lock. That's like. Okay, that particular previous example, there's a lock is there. If you receive the lock, okay, then the phase again want to string phase is need. Okay, string phase is need release the lock, not obtain the lock. That phase. Every transaction has a two phase. Okay, in the schedule. Okay, the protocol assure serializability. It can be, okay, prove that the transaction can be serialized in the order of the lock point. Okay, that lock point is there. They had a growing, the serializability is there in the schedule. First growing phase, then execution over, make for the stringing phase point. That is the point where the transaction occur in final lock. The two-phase lock protocol. Two-phase locking does not ensure the freedom for deadlocks. Okay, ensure freedom for lock. The cascading rollback is possible under two-phase locking. To avoid this, the following the modification protocol has strict two-phase lock. The two phase is there here. Lock is the one phase is the growing. The growing is the only acquire the obtain the lock, not acquire release the lock. But string phase is the release the lock, not to obtain the lock. Two phase. Okay, here the transaction must be all it exclusive. Lock still it commit to abroad. Okay, later we will do some exercise example, then you can clearly understand the lock code. Okay, occurrences. Two-phase lock is ever sticker. Here all locks are held to commit or abroad. Okay, in this protocol, transaction can be serial in the order in which they committed. Order of the committed, it take the lock. Two-phase lock protocol, there can be conflict serializability schedule that cannot be obtained if two-phase lock in use. Okay, it has the conflict serializability. Conflict means it is impossible to complete the transaction. Then it cannot be obtained the two-phase lock in the use. Okay, the two phase is there. One is the growing phase and stinging phase. The growing phase only obtain the lock. Stinging phase release the lock. Mean release the transaction, mean release the lock. Okay. Then if you write the transaction T1 like we make that is the first want to acquire lock, obtain lock, grant. Okay, request that. You want to request the lock, then the concurrent manager grant the lock. Then if the transaction seriability, that transaction end of the schedule is finished, execution is finished, we have to make that a phase as a string phase. Release the lock. Release the lock. Then after that we make for the growing phase. Obtain the lock for, if you possible to grant the lock from the concurrent control manager. Okay, we call the concurrent control manager mean the database has that okay features. If make for the grant the lock. Okay, however, the absence of the extra information. Okay, ordering of the access the data, two-phase locking is need for conflict seriability if the following sense. That also is given the transaction TI that does not follow the two-phase locking. We can find a transaction TJ that use two-phase locking and a schedule for TI and TJ. That is not conflict seriable. Then it can execute. Lock conversion. Two-phase locking with the lock conversion. Okay, conversion. The first phase can acquire the lock S on the item, can acquire the lock X on item, S lock and S lock. Can convert lock S to lock X, upgrade. Okay, then S lock means that's a chair lock. We can read, but we want to that acquire for the another lock as a X lock. Then we can upgrade for the lock as X, because the first phase means that's a growing phase. Only obtain lock. Then we can first we get the some S lock. Then after that we acquire the another lock as X lock. X is the exclusive lock. Read and write item. You can read and write item. Then that X lock to upgrade for the X lock. The second phase can release the X lock and release a lock X and can convert to the lock X to lock S downgrade. Okay, that's also going to release, but we can downgrade S. This protocol ensures the seriability, but still relies on the programmer to insert the various lock instructions. Okay, then automatically acquire the lock. Automatically you can write the program. Okay, the operation read D is processed as. Okay, the transaction TI issue the standard read write instruction without explicit lock call. Okay, now we check if the TJ has on D, lock on D, particular transaction, lock in the D. Then wait. Okay, else, if necessary, wait until no other transaction has the lock X on D. Okay, if they are going to wait, if there are no lock. Okay, if the TI has the lock D, then read the D. Okay, if necessary, wait until the no other transaction has lock X on D. The grant TI S lock on D and read. Okay, they are waiting for, there are no any lock in the D, then we can grant TI a lock S on the D. Okay, there is the lock is there, then we can read. Lock is not there, we are on to wait. There are no any lock in the D, then grant TI to lock X and D and read D. Okay, this is also automatic acquisition of the lock. Automatically you can get the lock. Okay, this procedure you can write that coding also. Okay, the automatic acquire the locks. If you write D is process as, want to write that. If you want to write, then you want to get the X lock as a exclusive lock. If T has a lock X on D, lock X means exclusive lock, then write the D. Okay, else begin. If necessary, wait until the no other transaction has any lock on D. Okay, if T has S lock on D, TI, then upgrade the X lock, exclusive lock. And after that, you want to write that D. Then grant TI lock X on D, and then you can write this. Automatically, you can acquisition of the lock. Both S lock or X. Want to read only. You want to read the particular item something. Only you need for the it's enough for the S lock. Here, S lock. Grant for the S lock. Only read. But we want to check. There are no the D hasn't any X lock for other transaction. X lock, exclusive lock. If you make the exclusive lock, then other transaction cannot use that particular item. Item in the record. D is the item. Okay, particular item. If necessary, wait that. Then we can automatically acquisition of the lock. Automatically you can acquire that. After lock are released, after commit or approve. Okay, they successfully, if your transaction okay, then you can commit or after approve. When we want to transaction is over, we want to write that as a release the lock. Okay, now it's a grant for lock, then a lock X on D. Okay, the implement of the locking. A lock manager can be implemented as a separate process to which transaction send lock and unlock request. Okay, then concurrent manager has the locking process. The lock manager reply to lock request by sending a lock grant message. Okay, if you one transaction waiting for lock, then if you the locking manager send to the message to the particular transaction to we grant the lock. Grant mean get the lock. Okay, message asks for transaction to roll back in case of the deadlock. Okay, if a deadlock is happened, then we want to roll back. The requesting transaction wait until its request is answered. Okay, then request transaction want to lock is need, they want to wait. It won't wait until its request is answered. It will get the lock. Okay, then grant the lock. The lock manager maintain the data structure called lock table to record the grant locks and pending request also. Okay, then lock manager maintain the data structure called lock table to record grant lock and pending request. Then one lock is released, the pending check the pending request, the need for the particular item. Then after grant lock, the lock table is usually implemented in memory cache table index on the name the data item be in lock. Now you can see that this is the lock table. This is the instruction 7 and 23. Then T3 here, this is the dark color, dark blue is rectangle indicate the grant lock. Already granted that lock. Lock is there. The T. Okay, item 7 is grant for the T3. Okay, lock table also record the type of the lock. Now is the item is grant for the schedule as a T1 and T8. Item 23. But T2 for waiting. Sorry, T2 for is the waiting. The table has that. Okay, this they have a schedule table, lock table. Okay, dark blue rectangle indicate the grant locks. Light blue ones indicate the wait request. Lock table also record that type of locks, grant or recurs. What are the type of lock? Is grant or recurs. Already we see that is the some lock table is there. Grant XBT1. That the lock table is there. This is the concurrent control manager. There is a grant XB or a lock exclusive lock for B in the T1 transaction in the T1. Here S lock grant A. Okay. These records are there. Okay. The new request is added to the end of the queue. Okay, it's a queue by queue, they are waiting. Or request the data items and grant if it is compatibility with the all earlier locks. Okay, now you can see here two locks are there. Sometimes it's the one is S lock and this lock. But sometimes that lock, the different item is there, no worry about the lock. But the same item is there, but lock is need. Unlock request results in the request being deleted. Okay, if I unlock this request, okay, now is the lock is here, grant lock. Then that transaction T3 requests to unlock. Then unlock is want to delete. Okay, then lock is going to delete. Unlock request results in the request being deleted. The later requests are checked to see if they can now be granted. Okay, now that T3 is request this one, lock is there, grant. If you finish, then T3 lock to another one also. Okay, but in that item 4, okay, lock to T1, but T23 request for this item lock. Item 4. Okay, waiting. Then if your T1 is finished, release that lock, then T3 can get the lock. T23 can lock them, get the lock. This item 44. Okay, echo the lock in T8. Transaction 8, echo the lock. It's a transaction abroad. All waiting or granted requests of the transaction are deleted. Okay, some particular transaction is abroad, means the rollback. All waiting or grant requests of the transaction are deleted. Now is the, for example, now is the T3. Particular T3 is T23. Sorry, T23 is abroad, rollback. Then all lock are released, delete. Okay, or waiting things also going to delete into T23 on to delete in that lock table. Because can't execute, because this one is a schedule, serious, okay, continuously execute the transaction. See, that's like this like. But in this point is something happened, rollback. Okay, T23 abroad. We cannot complete the other transaction because we want to go to the previous thing. Then it roll back this here also, then delete that particular T3 if you're waiting or granted request also abroad. Delete. Lock manager may keep it the list of lock held by each transaction to implement this efficiency. Okay, this is the lock table. Graph-based protocol. Graph-based protocol are an already two-phase locking. Okay, impose the partial ordering on the set of D. D is the D1, D2, all data items. Okay, if DI, okay, go to DJ transaction, that any transaction exceeds the both DI and DJ must be accessed DI before accessing DJ. Okay, if the order of this there, graph-based order protocol is there, then data transaction I need for the DI. Then first complete the DI and after accessing DJ. Implies that the set D may now be viewed as the direct acyclic graph called database graph. The three protocol is simple kind of graph protocol. Now is the graph protocol. Okay, A transaction, that item A, B, C, D like. Okay, only exclusive lock are allowed. In here, the protocol T protocol is there, only exclusive lock. No. Okay, first lock by TI maybe on any item. Okay, any data item. Subsequently, a data Q can be locked by TI only if the parents of the Q is currently locked by TI. Okay, data item may be locked at any time. Okay, lock any time. A data item that has been locked and unlocked by TI cannot be subsequently be released to be subsequently be relocked by TJ. Okay, TJ. Now here you can see. Okay, but if the here T transaction T10, T11, T12, T13 is there. T10, T11, T12, T13. There are also locks granted here. Okay, they are lock. But in this transaction schedule, here is the lock XB. Okay, if you lock XB is there, okay, anywhere you cannot get until unlock the D. Okay, this is the transaction schedule T10, T11, T12, T13. Now you can see X lock item B got the lock. Grant that lock is the in transaction 10. Item B lock granted to the item in the transaction 10. Now you can see up to here unreleased. Then the T12 lock the XP. Okay, there are no things. Here is the lock D that after a particular time lock XB. Then T11 request the lock D. Then now granted. If you unlock there, then now the T10 request that lock in. Okay, grant for to the T10 that item D. Okay, up to now here item D unlock because item D is using something in there are instruction not here writing or reading or writing. Now that operation not been included here. Only lock and unlock schedules there. Okay, some transaction have some operation happening here inside. Okay, that is a thing. Now here up to D is here, unlocked. Then after that, T3 can lock D. Okay, T3 can lock in the D. T13, sorry, T3 or T13. Lock in the D. Then after unlock D. Okay. Then here is a T11. But we want to put the schedule. Without schedule is the problem. In here is grant for the D. Sorry, B. The D also put here, lock XB. If you grant for the D, lock, okay, lock D for T10, then here cannot grant to the T11. The D can't, D, okay, lock D cannot grant for the T11 or T11. Therefore, the schedule also there. Then according to the schedule, the concurrent manager grant to the lock. Okay, according to the schedule. Without schedule is a conflict. Sometimes deadlock is. But the protocol is there, lock protocol is there, it is managed to the schedule. Okay, graph-based protocol, the tree protocol ensure the conflict seriability as well as freedom from the deadlock. There are no deadlock is freedom for the deadlock. The tree protocol ensure that seriability well as a freedom from the deadlock. Unlock may occur earlier in the tree lock protocol than in the two-phase protocol, locking protocol. Okay, in here we can happen unlock for before that tree base. Shorter wait time and increase the in concurrency. If you use for the graph-based protocol, this is the advantage, shorter wait times. Okay, wait time is short and increase in the concurrency. Protocol is deadlock free. No rollback are required. Okay, there are no any deadlock, there are no any record for the rollback. But in the lock protocol, okay, lock protocol, it may be happen in the deadlock. If a deadlock is happen, the rollback is required. Rollback protocol does not guarantee recoverability or cascade freedom. Okay, this one no recoverable process. Okay, need to introduce the commit dependency to ensure the recoverability. Want to sure. Okay, make sure this introduce the commit dependency to ensure the recover. Because the rollbacks are not there, then not necessary for recover. All are successfully complete. Okay, transaction may have a lock data item that they do not access. Increase the lock overhead. And additional waiting time potential decrease in concurrent. Okay, in the rollback it has that is the increase the lock overhead and additional waiting time also there. But in the graph-based protocol, it is there are no any rollback. That's a short waiting time. Schedule not possible under two-phase locking are possible under the three-phase and vice versa. Okay, schedule not possible under two-phase locking. But in here, three-phase schedule is needed. Okay, in the here, okay, this is the tree protocol, but the schedule is needed. Okay, because the schedule mean this is the millisecond. Not in you take for the 2 hours, that time is the schedule is the every action, you know, that's every action. The transaction happens within second. That's a schedule. Okay. Deadlock handling. How to handle? Consider the following two transactions. T1 write X, write Y. T2 write X, write Y, write X. Schedule with the deadlock. Now it's a lock X A on A, write A. Okay, write A. Lock X on B, write B. Wait for the lock X on A. Okay, this request for the locking onto something, but in still here, right, lock NX X on A, lock X, actually lock is there in the A, the transaction 1, write A, not release. Then it is waiting for life. Then again you write that another command, okay, wait for lock X on B, you want to request. But in here, lock B is there, but write B is there, but no release. It's the deadlock situation. Okay. If here is unlocked, then T2 can use A, because T1 lock the A. Okay, this is the schedule with the deadlock. The schedule is there, but the deadlock is come this here. Deadlock handling system is the deadlock. If there is a set of transactions such that every transaction is the set is waiting for another transaction in the set, then you can prevent to the deadlock. Protocol ensure that the system will never enter into the deadlock state. Some prevent strategy. Okay, then you want to prevent that deadlock. Already you understand that deadlock means if you put the lock in A, the transaction, put the lock in the A. But in the after read the A, then the transaction T2, transaction T2, wait for the lock A, want to use the A, but not release here, is waiting. But in the T2, lock the B, write the B also, but not release, unlock. But the A want to wait for the B. Okay, the T1 waiting for the B, T2 waiting for the A. But they both are not released, the items. Then continuously they are going to wait. This is the deadlock. Okay, how to prevent? Prevent strategy. Secure the each transaction lock all its data item before its beginning execution. Okay, pre-declaration want to make. Impose the partial order of all data items and secure that the transaction can lock data items only in the order specified by the partial order. Okay, graph-based protocol. Order, we want to order for the request, require transaction. The following scheme used to transaction time span for sake of the deadlock prevent alone. Wait die scheme, non-primitive. All the transaction may be wait for younger one to release the data time item. And we can make for the time span. Okay, wait die scheme and good wait scheme. One is the older transaction. You make the transaction the older one. May wait for younger one to release the data item. Okay, all the transaction is lock is there. It can release for the younger one to release the data item. For younger one to release the data item. Younger transaction never wait for older one. They are rollback in seat. Otherwise, rollback. A transaction may be die several times before acquire the need for data item. The transaction may be die several times means rollback. Okay, would wait scheme primitive. All the transaction would forced to roll back of younger transaction instead of the waiting for it. Okay, then if you younger one is waiting for the that particular item, then older transaction forced to roll back. Younger transaction maybe wait for the older one. Otherwise, maybe if you will roll back that wait die scheme. Okay, deadlock prevent both wait. Okay, wait die and would wait scheme. A rollback transaction is restarted with its original time span. If you give that particular time to complete the transaction and lock the particular item. If the time is over, release. The transaction such as preceding over newer one and savation in the avoid. The time out base scheme. The transaction wait for the lock only for the specific amount of time. Okay, the transaction only wait for the specific time lock or lock for only. After that, the waiting time out, the transaction is rolled back. Okay, the particular transaction wait for the lock. The time is over, roll back that. Okay, thus deadlock are not possible. Therefore, deadlock is not possible. Then the previous here is that deadlock is there. But if you wait for the lock for the particular time, the time is over. Okay, roll back this one transaction. There are no any problem for here. You can look for the B. If you roll back the T2, okay, if you brought that T2, the lock X you also release. Then T1 can use to lock the B. Okay, this is a time base out. Give the particular time to waiting. Okay, deadlock are impossible. Simply to implement by starvation is possible, or difficult to determine the good value of the time out interval. Okay, that is the problem. How long want to wait? That's the they want to give for the time interval is the problem. Otherwise, it is the best for the time out based scheme. Okay, deadlock detection. Deadlock can be described as a wait for graph, which consists of a pair G, V, comma E. V is the set of vertex. That's a horizontal line. All the transaction in the system. E is the set of H. Each element in the order of the pair Ti, Tj. If Ti, Tj is the E in E, then there is the direct to H from Ti to Tj, implied that Ti is waiting for Tj to release the data item. Okay, then Ti is waiting for that Tj to release the data item. Okay, then we can prevent for the deadlock. Wait for. When Ti requests the data item currently being held by Tj, then the HTI Tj is inserted waiting for graph. This H is removed only when Tj is not longer hold in data item need to by Tj. Okay, that is the thing we want to give for the time frame to wait and release. The system is the deadlock state if and only if wait for graph as a cycle. Okay, must invoke the deadlock detection algorithm periodically to look for the cycle. Okay, then want to make the deadlock detection algorithm. If the deadlock is there, then give for the time to give force to release the deadlock. how to that roll back particular transaction. Okay, particular transaction want to roll back. That's the okay, that deadlock detection. Now is here you can wait for graph without the cycle. Now is here T7, T18, this is T17, T18, T19, T20. And if you complete T18, waiting for the both T17 and T19. If you complete both, then T18 execute for the T20. Okay, wait for the graph without a cycle. Wait for graph with a cycle. Now is here T18 want to execute T20, but T19 also. But T19 want to complete, T20 is complete, then T19 also execute T18 because T19 depend for the T20. Waiting for graph. Now here, now the T17 is there. T17 is execute. It go to the T19, want to execute, and T18. But if you T18 is execute, because T18 is depend for the T19. T19 is execute and T18 on okay possible to execute. Because the T18 depend for the T19. Some changes want to happen like. Okay. Then T18 is execute complete, then T20 can execute. Now this is the deadlock. They are waiting something. If you complete, then like. Now this is the cycle. Okay, this is a cyclic transaction. Now we can deadlock recovery. When the deadlock is detected, some transaction will have to roll back. Okay, made a victim to break deadlock. Okay, now is here. Now you can see the deadlock is there because T20, if execute the T19, it's possible to execute. But the T18 waiting for the T19. But the T20 want to execute, but T19 is complete. If the T19 is complete, then T20 can execute. It's the deadlock. Therefore, we want to roll back some transaction. These are transactions, we want to remove this transaction. Otherwise, can't complete the all transaction. This arrow. Want to, this transaction want to remove the graph. Roll back. Determine how far to roll back the transaction. The total rollback, abort the transaction and then restart it. Sometime want to roll back the whole transaction. Now is the 4 transaction want to roll back, or partial part of the transaction want to roll back. That's the difference. Some transaction will have to roll back, made a victim to break deadlock. Select the transaction and victim that will be okay. Equal and minimum cost. Rollback. Determine how far to roll back the transaction. Then we want to determine which transaction we want to roll back. Abort the transaction and then restart it. And reschedule the transaction. More efficiency to roll back transaction. Only as per the necessary to break the deadlock. Okay. Such deviation happen if the same transaction is always choose as a victim, include the number of rollback, the cost factor to avoid the deviation. Okay, now I am going to stop. Then next week I will arrange the class. Okay, I want to discuss with you also. We want to arrange, students, want to arrange that project presentation. How is the project state, group project? Okay, you on the Mac and talk with me.
When we are going to hold the presentation, sir?
End of this month or first week of March. Sorry, not March, February. It's a, what is the state for your present project? You are complete or not? Already someone asked for me, then I send the mail. You keep it that project. Then when like I will schedule the presentation meeting.
Our team is okay, sir, but I don't know about others. I think
Okay. Then you can send to the team members to me. Then I can make the group title of the project and team members to mail to me. Then I can schedule first which group something, because without that information, everyone I can do first, I can do second, like that's is happen. We cannot make the schedule. Therefore, if you pass that message to all students, if you make that group project, then you can send to that schedule and a title with the group members. Then I can make that schedule and send to that email to you. Then according to that, we can start the presentation.
Okay, sir.
Okay.
So we have to email our group member names, our project name, right?
Project title. Then I can make that as a project title. That's the time also allocate first order.
Okay, sir.
Orderly you can present. If you like all members want to present, it's okay. Then I will give for the time frame. Only you have to make the presentation with the demonstration. Okay. Only 7 or 8 minutes for the presentation. What are the objective requirement? What is that? How to do that? Like then after you make the demonstration for the 7 minutes. 15 minutes for each group, and I ask for 5 minutes for that discussion or something. Okay, then 20 minutes for each group. Then separately you can send for the visual programming and database system and programming to project.
Okay, sir.
Okay, then send it to me. Then I can make the schedule. Without schedule, can't.
So after the presentation, we have to send the project file and other things, right?
Yes, later, yes. I make something, yes. Or sometime only presentation also okay, but you can keep it that this situation, you can keep it that your folder, because I want to need that is put the marks.
Okay, sir.
Okay, one person gave, sorry, ask some. What is it? More chat. I think there are some more slides you for today. Please, shall we get this? Okay, already I upload the new one in the LMS. Okay, I add something for that. That's I quickly make that presentation. I go to that our book also. Already I share with you all in the LMS that book. Read the book. If you unclear something, you can read the book where there is a good book for that you learn. Okay, these are the important things for that you develop the database, concurrent control. If you that is the small database, no problem. 1 or 2 user use the database, is the concurrent control is no problem. But if you huge number of people use that database, is the that's a banking like that's a one huge customers are there. Then how to handle, because the different person use for the one record. For example, you have the bank account, then you had the loan and other settlement or something. That is the thing. Then you want to update your data. your money. Then at the same time, 2% access your data. It's a conflict. Then we need for the concurrent control. Okay. I think some more is there. I think how many? Okay. Because this is a little big one, then we start the other two subjects. There are two chapters. Two more chapter is the recovery and distributed database. Distributed database is a small chapter, but recovery is a little big. But this one is a concurrent control is a big chapter. Okay, thank you very much. Then you can send to that mail, then I will make that. I don't know when you, sometimes second week of the March or February or something, I will schedule, but first want to get the all details, your details. Okay, thank you very much.
Thank you very much, sir.
I am going to wind up, stop that meeting.
Okay, sir. Thank you very much.
Okay.